Okay, it's already recording. So I asked if any of you already know the Pandas library for Python. Okay, there are a couple of people who say that they know. Okay, okay, very good. I see that some of you already know this library. Perfect. Well, maybe this session will be very introductory for you, and maybe you already know all what I'm going to count. But well, it's never bad to remind the context. So first of all, we need that you have installed any version of Python. Well, it's better if you have Python 3, okay, but I mean, you need an interpreter of Python. I don't mind if it is a console or if you have, for instance, Anaconda or something like that. Well, so does anybody not have the a Python interpreter? Do you already have it? Yes, for instance, I don't know if you have anacondas, spiders, or something like that. PyCharm, yeah, that's also correct. Well, I have anaconda, sorry, like this, and I'm going to work with JupyterLab. I don't know if you know it. It's very useful because you can have in the same, well, it's a web-based interpreter, and you can write text, combine it with cells or for executing Python and so on. Okay. Well, if you don't have anything like Anaconda, spiders, PyCharm, or anything like that, you should download it now, okay? Because I want this class to be like more interactive. I'll be giving you examples, and I want you to try to make them also by yourselves. Well, you can also, if you have Python interpreter, you can also type it like this. Sorry. Well, okay. And but okay, this is more elegant. I'm opening it. Sorry. Okay, here when I click here on Launch JupyterLab, I get this window which is in my web browser. Okay, it's completely web browser based. Here you can select the kernel to use. Well, I'm going to use Python 3. So, and here I can start writing Python code. For instance, I can say, okay, whatever in Python, okay? Here I can import whatever. For instance, I'm going to write this, import pandas as pd. Okay. So, should I wait for anybody to install something like this? Or I can continue? Okay. I assume that all of you have something like this. So, we are going to see today that here you see the data wrangling part of this topic. Okay, We will continue with data visualization. I don't think that today we can start with data visualization, but okay, if we can, it will be great. Do you know what data wrangling is? That's the first question. What is the data wrangling? No idea. No idea. I don't know. Yeah. Mhm. Yes. Yeah. Sorry. Sorry. Okay. Well, yes, it's more or less like that. Also, data manipulation, data cleaning. Of course, that data wrangling is to get your data ready for learning from it. Okay. It is divided also in data exploration, data cleaning. Okay, data cleaning is a part of data wrangling. Data wrangling is getting your data ready to learn something from them. So today we are going to see just the data exploration part. Okay, with pandas, pandas is one of the most important. Well, data wrangling is one of the most important stages in data analysis processes. We are going to prepare them for its correct pre-processing. Sorry, for its correct processing. Okay. So pandas. Now, pandas is an open source library which is written for Python. I think that you can also find it as an standalone application, but in this case, we are going to use the library which is written for Python, and you can use it for data manipulation and data analysis. Okay. First of all, Pandas is not, I think, is not already coming. Well, I wrote here Anaconda because I'm working with it. But if you are working with any other interpreter, you can also adapt it to your own environment. Uh, you can anyway install the library by typing this in your console. Okay, you can just type pip install pandas and it will be automatically installed. If you're working with Anaconda, you can check if it is already installed here on environments. Well, I made a quick search here. So if you write it, if you write here pandas, okay, you see that I have already installed it. If you don't have installed it, you can look it for here, not installed, or in any way you can launch here a prompt and just type pip install pandas, and that's it. Okay, I have already installed it, so it's not necessary for me. So now, to work with pandas, there are two common types of structures in pandas, okay, which are series and data frames. The series is a data structure of just one dimension. Okay, it's like an array. It's a labeled array, which is capable of holding any data type inside, but all the elements in the series must have the same type. That's very important. You cannot mix whatever you want inside a series. It's not like a list. Okay, in a list, let me write something here. Okay. You may have this in a list. There is no problem, but not in a series. Okay. For instance, well, we are going to create a series with a list, giving a list as with the elements to create it. So for that we have to write pd, because said that I'm going to use PD to making reference to pandas. PD.series, and I'm going to give, for instance, this. Okay, and it works because both of them are numbers. But if I say this, well, it was not supposed to work. Well, this is a surprise for me too. Maybe it's because a new version of Pandas or whatever. Because before it was not supported this. Okay. Well, well, I already know why it is working, because here you see that it is saying that the type of the series is object, like a very generic type. Okay. But before it was saying that it was an integer. It's like if I write here like this, it interprets it as a float. And okay, this is of type object. Well, anyway, so I should remove this before uploading it. Okay. Anyway, in the most common structure with which we are going to work are data frames. Data frames are also labeled data structures, but in this case, they have 2 dimensions. They are like tables, maybe mainly. And here the columns are of different types, usually. Okay. Here it's very common to have one column of one type, another column of another type, and so on. They are like this. Data frames are like tables in which data are organized in rows and columns. We have here an example. You have the column which is called name, height, weight. And then the rows, which are instances of a single person. Okay, we have here Ada, whose height is 58 and whose weight is 115, and so on. We can create a data frame with the following constructor. We can say just pandas or pd.dataframe. We can give the data to include in the data frame here, then index and columns. As I said, the data are the elements that we want to include in the data frame. It might be a list, a series, an array, a map, a dictionary, a constant, or even we can give another data frame. The index are the labels for the rows. One particular thing of pandas is that the rows are not called rows. The rows are called index. Okay, and well, here it should say also columns, which says that which indicates the labels for the columns. Okay. Well, so from the beginning, let's create an empty data frame. We want to create an empty data frame. We can write just pd dot. Wait a moment. We can write just pd dot data frame, and we get an empty data frame. This is the result, which is of course an empty element. We can store it in a variable like this. Okay. If you type it on the prompt, you will get something like this, which is more visible in this case. You get empty data frame, columns, index. Okay, let me show it for you. Python import pandas as pd, and now pd.dataframe. You see, you get here a text saying that it's an empty data frame with columns and index which are empty. Okay. So a very easy way to construct a data frame is just by giving a list. Of course, we can also say here the data frame now. Well, first of all, we can create the list. Data, and now create the data frame with the data. Now, if we get the data frame, you see that you get a new data frame in which the first and the only column is the list that we provided before. But you can see that, of course, maybe our intuition may say that the list will be a row in the data frame, but no, the list will be a column. Okay. Why? Because also usually the elements in the list, even if you can give different elements of different types, or if you give a series, are usually of the same type. And of course, when all the elements are of the same types, are in the columns. You see it, right? I got a question before. Yes, a question. Python and Python 3 are the same for pandas? Well, you have to be careful because it depends on the interpreter that you have, because there are different versions of Python. Well, you have Python 2 and Python 3. Are the same for pandas. Then I think that all that we are going to do is the same in Python 2 and Python 3, but I'm not sure. So to be sure, you should use Python 3. Does it work? Well, it depends. I mean, I advise you to use Python 3 always, because, for instance, there are things that do not work. For instance, error, and this works on Python 2, but not in Python 3. In Python 3, int is a function. In Python 2, it is not. So, and you should be careful, okay? Everything that we are going to see is for Python 3. I think that it also works in Python 2, but I cannot ensure completely, okay? For instance, well, you see here that all the prints are between parentheses. The parentheses also work in Python 2, but it's not the same in the opposite way, okay? Because in Python 2 you could use them with parentheses and without. Okay, you're welcome. Well, so I was saying that, of course, the result, and maybe you don't expect it, is that the elements are in a column, because usually, for instance, if we go back here, you see that all the elements in a column are of the same type. For instance, this column represents the name of the person. So all the elements are strings. here all the elements are integers. Here all the elements are integers. That's the reason why if we just give a list, it puts it as a new column, okay? Not as a new row. Like this, okay? You can also see, well, here and also here, that here we have a 0 and here 0, 1, 2, 3. These are the column name and the index or row names. If we don't say anything, by default, the names of both the columns and the rows are integers starting from 0, 0, 1, 2, even the columns, which is not very common in other libraries. Maybe it is for the rows, but not for the columns. And always any column and any row have a name. In this case, the names are just the numbers. We can also create a data frame using a list of lists, like this. Of course, you have to be careful in this case because you have to specify each row in a different list. And here you see a little difference with just giving a single list. If you give a single list, it is a column. But here, given a list of lists, the single list contains a row. And then you can give several rows by giving a different number of lists. Okay, so let me type it on here. Okay, you are also trying all of this on your laptops or computers, right? Okay. So now our new data is a list of lists. And here we say Alex, then new list, Bob, 12, new list, Clark, 13. This is kind of a matrix. And now we create a data frame with that list of lists. And if we print it, we get this. Okay. Alex 10, Bob 12, Clark 13. Like this. Okay. We can also create a data frame from a dictionary of lists. Do you know what a dictionary is? Sorry, an element for? Yes, yes, of course. It's like, yes, a mapping structure, an element point, another element. Well, it's something like this. You have it here. For instance, it's, of course, it's like, well, a dictionary is a set of pairs. Of course, the first element of the pair is called the key, and the other element, the second element, is called the value. Yes, I will provide you the slides, but after the class, okay? Before, I prefer you to type the code by yourselves, because I think that it's you will keep the context better. Okay, so I will give you the slides, but after the class. Anyway, I don't think that you will be able to copy from the slides since they are images. Okay, they are it's not actually text on the slides. They are images, but of course I will leave the presentation on Moodle. Okay, so as I said, a dictionary is a set of pairs. The first element of the pair is called the key, and the second element is the value. So here you have key name, and the value is a list. Of course, when you are using here a dictionary, the values, all the values need to be a list or something. Yes, mainly a list. And all the lists must have the same number of elements. Also, you have to note that here the elements, Alex, Jack, Steve, and the ages here, you already have a name for them. So when you are creating the data frame, these keys, the key part of the dictionary, will be the name of the column. So let me write it. Now my data is a dictionary. The dictionaries in Python are written between these, and my key in this case is name, and I have a list of names. Alex, well, it's not the same list. Jack and Steve. And now another element in the dictionary is the age, which is the key, and a list of integers representing the ages. Okay, well, if I print this, you get this. Now it's the same. I put this data in a data frame. Well, let me print. You see that as I said before, now as you have a key, it uses the key as the column name without saying anything here. You remember that we have a parameter column here, but we don't need to specify it when using a dictionary. It just takes the keys of the dictionary. But what we can do is to give the number of the rows, the number of the index, the name, sorry. We can write index equal to, maybe it's a ranking, so rank 1, rank 2, rank 3. And then you see that the 0, 1, 2 is now rank 1, rank 2, rank 3. You see, right? Okay. This is the same as we have here. We can also create a data frame from the opposite. We used before a dictionary of lists. Now we are going to use a list of dictionaries. Of course, the dictionaries are simpler, more simple now. We have just key, value, key, value, key, value, key, value, key, value. Of course. In this case, each dictionary is a row, and it's specifying the value of the column A, for instance. In this, let me write with this. Okay, this is a row, and we are specifying the values of columns A and B. This is another row, and in this case we're specifying the values of columns A, B, and C. Of course, you can note that here we are not specifying the value of column C. Therefore, we will have a null value there. Let's write it here, data, and we give a list of dictionaries. So first row, column A, value 1, column B, value 2. Now another row, E, or column A, value 5, column B, value 10, column C, value 12. And we can create a data frame with the list of dictionaries. Something is not correct. Let me check what I did wrong. Okay. Like this. I don't actually know why, but it is not letting me to okay, yes, I already know why. I am specifying three names for the index, but I only have 2 rows. So this should work. Yes. Okay, you see, okay. Well, in the slides, anyway, this is not included. And you see here that we have a not a number value, which is like a null. Okay, not a number. It's an empty cell. Like this. Well, you can also notice that this is converted into a float because of the not a number here. Okay. And finally, we can also create a data frame with a dictionary of series. It's very similar to the case of a dictionary of lists because a series is more or less like a list. Okay. So you see that we have here one column with 3 values, column 1 with values 1, 2, 3, and a second column with values 1, 2, 3, 4. You can notice that the series, both series, has not the same number of elements, but you can do it if you say to which index belongs each element. If you don't say it, it will give you an error. But if you specify that the 1 is for index A, the 2 is for index B, and the 3 is for index C, and so on, it gives no error. So, in this case, data is a dictionary, but in this case of series. 1 is a series. This is the name of the column. Okay, that's the same as here. Pandas.series 1, 2, 3. Well, we create the series from a list. You see that here we just use a list. Here we are using a series which is at the same time created from a list. But notice that here the index given to the series. It's not for the data frame because we are not creating the data frame yet. But the series also has an attribute which is the index. They do not have the columns. They have index. Okay. A, B, C. Well, this is a dictionary with just one series, but we are going to include another series, 2, which is also a Pandas series with elements 1, 2, 3, 4, and whose index, I'll copy this, and D. And something is not working. Well, yeah. It's the bracket. It's because this needs a bracket. This needs a bracket, and here a parenthesis. No. What's not working? Let me check. This works, right? Yeah. A symbol. Okay, we have here parentheses. Oh, okay. Okay. Thank you. Yes. Now we print this, of course. It's a little bit more elegant than here, but you see, you have two series, one with indices A, B, and C, and the other one with indices A, B, C, and D. Okay, well, and once more the same, put it into a data frame. You see that in this case, we are already giving the name of the columns 1 and 2 and the name of the indices A, B, C, and D. And of course, you can see here that we have not a number, like a null value. Okay. Okay. Well, we can also load our data from a CSV file, which is much more common than writing all our data just directly from in a list or unloading it or whatever. Usually we load our data from, well, not maybe not from a CSV, but we can also connect to a database or whatever. Okay. In this case, we are going to create a CSV file and we are going to load the file into Pandas. Well, so I want you to open a new notepad or a new application for writing text and write the text in this slide. We have the first row, which indicates the name of the columns, ID, name, height, and weight. And then in each row, in the following rows, we have the 5 elements, 5 rows with instances of people. ID 1, name Ada, height 58, weight 115, and so on. Okay, so please do it with me. and you need to save it in your workspace from where Python loads the files, or otherwise you will need to give the whole root to the file. Okay, let me save it. Okay, I'm going to save it with the name people, for instance, .txt. You see it here, people.txt. And now we can just load that dataset. It's a very simple dataset in CSV format with this function, pandas or pd dot read CSV, and giving here the name of the CSV that we want to load. As I put the file in my working directory, I can just give the name as a relative root. If you put it in another place, you might give the whole root. Okay, not an absolute, the absolute root, not a relative one. The absolute path. So pd dot read csv, and here, well, uh, txt, and you see that I already have it here. Okay, I can also store it in a variable like this. There is also a read CSV too. Have you encountered any events when you use that one? Actually, don't know why. What's the difference? Let me check, because I didn't know that there were another function. Let me let me check what's the difference between them. Like this. Well, I was not finding it on the in the documentation, and it doesn't work for me. Where did you find it? Oh, maybe it's in R. Here it doesn't work. It doesn't exist. The CSV. Ah, okay. Yeah, the separator is the colon and the decimal is okay. Then the CSV2 works with Spanish, then with Spanish format, since in Spanish we use decimal separator as with the comma, and the separator of fields with the colon. Okay. Here you can, I think that you have a parameter which is sep to say the separator. Let me check. Yes, of course. You can write it here, something like this. Oh, okay. Yes, of course. Writing set equals to the column. Okay. But I think that there is no way for changing the decimal separator. Okay. So this is what we get. Well, here you have more options, of course. Separator, the comma is the default. You can say, even it's the default, you can also specify, well, we are going to try it. Oh, there is also a decimal, okay. Then you can change it. You can say here, header, for instance, equals to 0. Equals to 0 is the default value also. And the names of the columns. Be careful, since in the constructor, for giving the name of the columns, we needed to use, well, for instance, here, for giving the name of the columns, we need to write columns. Okay, but here in the read CSV, it's not columns, it's names. Okay, so be careful with this. And the name of the columns, well, wait a second, wait a minute. Well, no, I made a mistake. Here equal to 0 means that that we are not going to use the default names which are included in the file. Okay, but we are going to use another names. For instance, we had ID, name, height, weight, but here I can say identifier, name, height, weight, and let me print. Okay, you see that we are overwriting the default names by saying header 0 and giving our own names for the columns. Okay. Oh, yes, because here instead of name, it was saying first name. It's the same, but saying first name. Seems to me that the number after header is the line that will be used for columns names. Yes, but 0, when you specify 0, let me check. And column names are inferred from the first line of the file. Yes, but you have, I'm looking at the documentation, okay, and it says that explicitly pass here equals to 0 to be able to replace existing names, because we want to replace names that already exist. Therefore, we need to specify the 0. Let me check what happens if we don't write header equal to 0. Because if you don't write this, maybe it can think that the first that this is already a row. But let me check. Yes, this is what happens. Correct. Mm-hmm. It thinks that the first line of the file is already a row. So you need to write this. Okay. Okay, no problem. Well, you can also change the row in which the name of the columns are inside the CSV. If you specify header equal to 2, 3, 4, 1 is the default. Okay. You can also specify none if the dataset has no names for the columns. Okay. Note that this is different. By saying none, you are saying that there are no names in your file for the column. Okay. And we can also have into consideration that maybe our dataset has already an attribute which might identify its element, its instance. For instance, if we are in a database, if we are retrieving the data from a database, you have the primary keys, which are usually a number, an auto-increment number or something like that, which identifies a row. In that case, you can also use this parameter, index call. What is the difference between header 0 and header none? Okay, with header 0, you are saying that your dataset has the name of the columns in the first line, but you want to replace those names. But here equal to none, you are saying that your dataset has no names for the columns. Okay, 0 means I have names, but I want other names. None is it means that the file does not have column names. Okay, is it clear now? The difference? Okay, no problem. So index call. You can use this parameter to specify that one of the columns, one of the features can be used to identify its row. For instance, here we have a column which is ID, which can identify its row because it's just an auto increment number 1, 2, 3, 4, 5. So here we can say even, well, I'll write it in another cell. I'll remove this. Index call, which says this is the column for giving name to the index. And I say that in my case, this column is ID. And you see that now I have the ID name written over the column of the indices, the index, and I don't have the ID column here. And also you can note the difference because before the index was starting in 0 and now it's starting in 1 because I wrote here 1, 2, 3, 4, 5 for the indices. I can also, or for the ID column, I can also, well, write it with letters like this. Now if I load it, you can see that the ID column, the index, is A, B, C, D, E. I can refer now to its instance with A, B, C, D, E. Okay. So this is what we get. Well, now we already know how to load data. Now let's operate with columns. Okay. You can get a column by doing something like this. Data frame, we store the data frame into a variable, and we write the name of the variable, data frame, and between brackets we write the name of the column that we want to get. Okay. Let's write that series. Okay, we are creating a data frame using a dictionary of series. Data are, first column is going to be called 1. Well, actually it's this. You can just copy and paste. Okay. And we are going to select only the first column. Okay. And what we obtain is a series, because you see here that you have the name of the row, the name of the index, A, B, C, D, and the values. We obtain a series. Okay. Well, we can also add a new column. It's very easy to do it. Just to create a new column or to append a new column to an existing data frame, we can just well, we can do it from a list, a series, or even a combination of other columns. Oh, the animations are not correctly ordered here. Well, for instance, we want to add a column which is called 3. So 3, we just access to that not existing column, to a column that doesn't exist yet, and we say data frame of 3 equals and to the series that we want to append as a column, or data frame of 4. If you remember, when we were creating a data frame from a list, it was a column. It will be the same here, because data frame of 4, we are using a list to create that column, and it will be actually a column. And we can also create it with columns of an already existing data frame, because actually this is a series and this is another series. So they are series and we can create a series. And when we are summing two different series, we get what it actually does is the operation, in this case the summation, of element by element. Okay, so let's append this column, which is called 3, and it's a series with elements 10, 20, 30, and of course we need to give the index here, A, B, C, D. Also the column 4 with a list, and column 5, which is a combination of column 2 and the new column 3. And we print the data frame. Error. Something is wrong. Let me check what's wrong. Here it says length of okay, because I wrote here 3 elements and 4 indices. What is the case in the example? Okay, it's just until C. This. Okay. Here you see that I'm summing in the last row 4 with not a number. 4 and null gives us as a result null, not a number. Okay. Okay, this is the result. Any question? No? Anything that you need me to clarify? So let's continue. Okay, we have seen how to select a column and how to add a column. Now let's see how to delete a column. Okay, we can delete a column in 2 different ways. The first one is to modify the original data frame, which returns the deleted column, which returns the deleted column. Okay, so I didn't show the example. It's the method pop. If we say pop column 5, it modifies the current or the original data frame. It deletes the column from that data frame, and it returns the column as a result of the operation. Therefore, we can do. Well, it's not exactly what is written in the slide, but we can do something like this. Column 5 equals data frame dot pop 5. This will remove this column from here, and it will be returned by the method, and we will store it here in column 5 variable. Now, if I print the data frame, you see that the 5th column is not here, and if I print column 5, I get that series. Okay, the series corresponding to column 5 here in the data frame. And we can also we can also delete the column, but not modifying the original data frame. We can create a copy of the data frame, but without the column or columns that we want to delete, because in this case we can specify a whole list. It's not just one column. We can specify any number of columns. Okay, well, with the method drop, and here giving a list of names of columns, we can delete a given number of columns. We need to specify another parameter here, which is axis equal to 1, because by default it deletes rows. This method drop by default deletes rows or index, okay, which is axis equal to 0. Axis equal to 0. With this parameter, we delete rows, and it's the default behavior. But if we write equal to 1, we are going to delete columns. So let's see an example here. I say, for instance, DataFrame2 equals to DataFrame dot drop. I can give here a list of columns, maybe only 4, and axis equal to 1. And now if we print the original variable data frame, we see that the 4 column is still here, and data frame 2, we see that it's the same as the original data frame, but without the 4 column. I can also write here this, for instance, and it removes the columns 1 and 4. Okay. We can also select a range of rows with this. Data frame, well, let me, well, from 0 to 2. As in the range function, here the 2 is not included, but the 0 is included. So zeros, 0 and 1, because 2 is not included. But here there is a problem, that because this selection operation can only be performed with numbers. If you want to select a row with the brackets, you can only use the equivalent in numbers. You see that here we have names which are A, B, and so on. But we cannot specify A, B, because here if we write A, it will think that it's a column. And of course, we don't have a column which is called A. Okay, only with numbers. There is a function, it's not in the slides, but let me, because I wanted to add it, but I didn't have time. I will show it anyway. Yes, which is the function or the method loc. It's for locate. Okay, with this function we can get a row by its name. Here, if we say tf.loc, and I want to locate row B. No, it's a list of names. Yes, we need to give a list of names. No, not working yet. Okay, no, it's not actually a function like this. It's a variable of the data frame like this. You see that it's returned as a series, but a series not of the column but of the row. 2, 2, 20, 99, 22. Okay. Also, I wanted to show you something that is not in the slides. I wanted to add it, but I couldn't, which is this add. We can get a single value given the row and the column pair, the labels, giving the labels, okay? So we can just say, for instance, add row and column. Let me show it to you. For instance, we want to get the column 3 of element B, this 20. So add, we always say first the name of the row, B, and then the name of the column, 3, 20. Or let's get this not a number. Row B, column 5. Well, it says that, oh, yes, because I removed the column with the pop. Then this, not a number, from column 1, not a number, okay? You can also give, instead of names, well, it says that you can also first get the row with log and then get the column with that. But I think it's easier like this. You can also use I add. I add is the same, but giving instead of the names, the index of the column and the index of the row. I mean, this is row 0, 1, 2, 3, yet 3, and column 0. Okay, and the 20 is row 0, 1, column 0, 1, 2. Okay, and the same with I log. For instance, to recover the second row, like this. Okay, these functions were not in the slide, but I wanted to explain them because I think that they might be useful at some point. Sorry. Okay. So anyway, we can also select a range of rows like this. I think that you can also do it like this. I log 0 to 2. Yes. But you see the difference here. Here you have a data frame and the result is only a single row. It's a series. Here it's the same than writing. Oh, sorry. This, okay. Well, add new rows. In this case, what we need to do is to create a new data frame and append both data frames. For instance, well, not with this example here, but I'm going to create another example. I'm going to create a new data frame 2, with this element. Oh, sorry. pd.dataframe. Okay. You see what I did for having a row instead of a column, right? I wrote two brackets to say that it's a list of lists and I'm only having one element in the first list. It's like a simple trick. Well, I need to specify the same names for the columns so that it doesn't, so that it works. So columns are, well, actually the fifth column does not exist anymore. So columns are a list with 1, 2, 3, 4. Okay, now I can append DataFrame 2 to the original DataFrame. So I have to write df append df2. And you see that we get this. It doesn't modify the original data frame. So if I want it to modify the original data frame, I need to write this. Oh, sorry, it modifies it. Now you see that we have the same row twice, right? And this is something that I also wanted to see. Now we have two rows with the same index, 0 and 0. Let's see what happens. Now, okay, yes. But in place equals to true, it will combine the rows with the same index, maybe? Moment. Okay. You mean to not to modify the data frame, but to obtain a copy, right? You can do it, of course. But it was because it's a confusion that I had because I thought that it was not modifying the data frame. But anyway, it's okay because I wanted to show you something here. Now we have a replicated index here, 0 and 0. But, well, in this case, maybe it's not. Look, what is happening here? Let me. Okay. It's log 0. Well, you see that we have two rows with the same index. If we have two rows with the same index and we access that index by the row with that index, we obtain both of them. Okay. And also, if we drop by, if we call the drop function, drop, well, this is the way to delete a row. Okay. It drops both rows as well. Okay. Well, to add new rows, then we need to append two data frames. And to delete rows, we use the drop function with axis equal to 0. Equal to 0 is the default behavior. So actually we do not need to specify it as I did here. Okay. We can also say, okay, by default, drop does not modify the data frame. So if now I access the whole data frame, it's still like this, okay? No problem with that. Good in this. Okay. Any problem with this? No? Can we continue? Okay, perfect. Well, more operations with data frames. I can access attribute T of the data frame, and what it returns is a transposed data frame. It's like a transposition of rows and columns. So here, if the data frame is like this, and I access this, it's the same, but like a transposition of matrices. Okay. Here, let me check something. Okay, here we have a column which is name, height, weight. Let me check. Well, it works. Yeah, I said nothing. Well, if I access the attribute axis, I get the list with the labels of the rows and the columns. So df.axis, it gives me the names. First of all, the names of the rows, A, B, C, D, E. And, well, it's not giving me the zeros because I modified. Well, let me load this again. This, 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 this. Okay. You see here that I get A, B, C, D, and 0. If I append again, 0 is twice here, and the name of the columns 1, 2, 3, 4. Okay. I can also get the types with the attribute D types. The first column are floats, integers, floats, and integers. Empty, it indicates if the data frame is empty. Any axis has a length of 0. Empty, which is false, obviously. I can write this, which is true. I create an empty data frame, dot empty, true. Tape is a tuple with, that indicates the number of rows and columns. The first element is the number of rows, and the second element is the number of columns. Size is the product of the two previous numbers. Size 6 times 4, it's 24. And values returns an array of NumPy that contains the values. Okay, it's an array of the NumPy library. It's like a matrix in this case, an array of lists. And we can also have these two methods, head and tail, to return the first or the last rows of the data frame. For instance, well, I can just say data frame dot head it returns by default the 5 first rows. DataFrame dot tail the last 5 rows. Or I can just say 3, and it returns in this case the last 3 rows or the first 3 rows. Okay? Which is actually the same as this. Well, okay. Any doubt till here? No? We can proceed. Okay, perfect. Now let's continue with the descriptive analysis, and here is where interesting things are arriving, because when we are going to analyze data, it's very important to have a statistical summaries of the data. For instance, we might know what is the minimum of a variable, what is the maximum. Maybe I want to know if there is any outlier, something like that. Okay, so first of all, let's load this data into a data frame. Okay, I'll copy it from here. Okay, you can do it at the same time as me. Data is I'm doing it like a dictionary of series. So the first column is the name. The name here I use a series, and the names are Tom, James, Ricky, Vin, Smith, Jack, Lee, David, Jasper, Bettina, and Andres. Now I have the ages. Age, go to a series, with ages 25, 26, 25, 23, 30, 29, 23, 34, 40, 30, 51, 46, and finally writing. A writing of each person, which is also a series. Sorry. Well, here we can invent Okay. Now we can create the data frame. Okay. Well, you can also add less elements. I think that I missed a name. Tom, James, Ricky, Finn, Smith. Oh, here, Steve. Okay, now correct. So with this data, maybe we want to get some summary of data. For instance, we can sum all the elements in a column. Okay. In fact, we can sum all the elements of all columns by separate, column by column, of course. Then I can just say data frame df.sum, and I get the sum of all the elements. Of course, what happens in the first column? The first column are strings. What's the what happens if we apply the plus operator to strings? It's like append. It's appending the strings. So sum actually applies the plus operator to the elements of the column. So for the first column, we get all the names appended. Okay. We can also sum all the columns of a row like this. Maybe it has no much sense, but we can do it. In this case, what we are summing are only the numerical elements. 25 plus 4.23 is 29.23. Okay. More methods that we have. Okay, let me see something. Okay. Well, we have the method count to count the number of non-null elements. Count. We see here that dataframe.count we get 12, 12, 12 in all the three columns, because all the columns have the same number of elements. We do not have not a number or null elements. Okay. Sum, we already saw what is what we obtain after applying sum. Min, it returns the mean of the column. Of course, in this case, it has no sense to make the mean of the names. So it only returns the elements of the columns which are numerical. Okay, because we can sum the names by applying the append operator, but there is nothing to do with the mean. Okay. Well, I don't know. Yes. The median, of course, with median we obtain the median of the values. The median of the ages is this, and the median of the ratings is this. The minimum, the maximum, the absolute value. Well, be careful because oh, with apps, yes, apps does not work with this because we have a column which is not numerical. If I do something like this, it will work. I'll drop the first column. I'm using the drop function which does not modify the data frame. Okay. If we would have a negative rating, for instance, it will be positive here. Okay, but be careful since the apps function cannot be used when we have a column with which is not numerical. Okay, all the other functions that we saw before, we can. For instance, you can also compare strings in alphabetical order. In alphabetical order, the minimum of the strings is Andres. Okay. Well, or calculates the correlation coefficients between each pair of numerical variables. Let's see it. Okay. It doesn't matter that we have a non-numerical variable, but it's only calculated between numerical variables. Then we see that the correlation between age and rating is very poor. There is no correlation at all. Of course, the correlation between age and age is 1, between rating and rating is 1, because actually they are the same variables. And this is a asymmetrical matrix. Is it the Pearson correlation coefficient or another one? I don't remember. The Pearson is the one which is based on the covariance and the standard deviations. It's like the covariance divided by between the multiplication of the two standard deviations, because I think it's that one. Yes. Well, it's. I think that in this one is for linear correlation. Then it will be that one. Let me check anyway. If it is the Pearson one. Well, actually, I see that by default is the Pearson coefficient, correlation coefficient, but you can change it. For instance, you can specify method. This is the default, but you can also specify Kendall and Spearman. Okay. Yes, but we are going to use the default one, but of course there are other options, these two options. Okay. Well, then you have cumulative sum. Well, I think it's once more because of the column which is not numerical. And oh, okay, I wrote consum. Maybe I don't need this, of course. Well, you see that has no much sense to apply to the name, so I'll keep this anyway. Cumulative sum, you see what it does, okay? It's 25, as the second element is 26, is 25 plus 26 is 51. It's the summation of all the elements which are above the current element and including the current element, okay? Also the same with cumulative product. Okay, you see that here you have very big numbers. You can also use describe to get a summary of statistics: count, mean, standard deviation, the minimum, the maximum, the 25th percentile, the median, etc. Okay. And apply allows you to create your own function and apply it to a function, a column, sorry. So for instance, let's see an example with this. We are going to create a numeric adder. We define a function, numeric adder, with fixing a list. We start by 0, and now for element in the list, we add to the sum its element, and we return the sum. Okay. Now, if I try to apply the function that I have defined to the DataFrame dot apply, I can apply the numeric adder function. It says error. Why? Because it's for numerical columns only, because I have defined it like this, and I'm adding here elements to an integer, and then I need an integer, of course. So what I have to do is to drop the column of the name. Drop name axis equal to 1. And then I get the sum of the columns which are numerical. Okay, this is what is written here. And we can also use lambda functions. For instance, here inside apply, I defined a lambda function saying that for each x, I divide x by the maximum of the rating of the column rating of the data frame. Well, we can also, instead of to all the columns, we can also specify a single column like this. Data frame rating dot max, it returns the maximum of the rating column. So with this, what I do is to this column, to the column rating, I divide its element, it's a lambda function, its element in the column rating, I divide it by the maximum of rating. What do I do? It's a normalization to put all the values between 0 and 1. So I can write here the f of rating dot apply, and here I say that I'm going to apply a lambda function for each element x. What I do is that element x should be divided by the maximum of the column. All the elements are between 0 and 1 now. Okay, like this. Well, and I'm going to keep the filters for the next session. Okay. I don't know if you have any doubt till now. Anything that you want me to clarify? No, no doubts. Okay, perfect. Then that's it for today. I don't know if next week I will be back here or Ernestina will be back, but if Ernestina will be back here next week, I will be in 2 weeks. Okay. So thank you, and see you the following week, the next week, or the week after. See you. Thank you. Let me